One of the big issues with voice commands in Home Assistant is out of the box, Home Assistant has no context about where you are when you issue the command. But what if I told you you could add that functionality with a simple template sensor? So we could ask something like, "Hey Jarvis, where am I?"
You are currently in the Slacker Lab studio.
And it responds with the correct answer. Not only that, we could take this device to another room. Okay, here I am in the theater with this Atom Echo. So what we're going to do is we need to change the area that this device is in. So we're going to pull up our HA app. We're going to go down here to our settings. We'll go to our devices and services. Come over here to these ESP home devices, and we're going to scroll down here to the M5 stack Atom Echo. And in here, again, just to show you that this is the device. Hey Jarvis. As you can see, we triggered it, but it's not set up for the right area. So we're going to open up this. We're going to come in here. We're going to change this area. And I'm going to put it in the theater. We'll hit update. Update again. And now, if we say, "Hey Jarvis, where am I?"
You are currently in the theater.
So all we did was change the area, and now the response for this plays in the theater. And that means things can get a little more exciting. "Hey Jarvis, it is too bright in this room."
The theater does look a bit bright. Here you go.
For voice commands to be really useful, I think it's important for Home Assistant to know which room you are in. For reference, for this video, I'm running 2024.11.2. Not that anything in this video requires that version. I just want to make sure you know the version I am currently using as I filmed this. Now, to get Home Assistant to know where we are when we use the voice command, all we need is a label, some areas, and a template. If you are new to areas and labels, I typically use areas to denote rooms in my house, and I use labels to group like devices. While that may be the normal way, you could really use them for anything. In order to build that last assistant sensor I used in the demo, let's assign an area and a label to our voice assistant. I went through changing the area pretty fast in the intro, so I wanted to make sure you had all of the steps. First, we're going to head to Settings. Then click on Devices. Then, in my case, I'll just head to the ESP Home integration. Depending on your device, you may need to go to a different integration. What you want to find is your voice assistant devices. In my case, this M5 stack Atom Echo is the one I'm going to update. From the integration, you should see a list of devices. Find your device and click on the device link under that heading. What you want to find is the Assist in Progress entity. Click on it, and then we need to click the cog in the upper right. On the screen, we can add our label. I already have Jarvis assigned to this one, but if you click the Add Label drop-down, you can choose an existing label or add a new one. For the sensor we're building, you'll want to have your Assist in Progress entities to all have the same label. Then, down at the bottom, you can change or update your area. By default, the entities that belong to this device inherit the area from the device. But you can't just change this entity to have a different area. Just click Change Device Area, and in the drop-down, choose a new area. You'll want this area to be the room this voice assistant device is in. When we're done, we click Update. A better way to change area might be to click the pencil in the upper left though. Here you can change the area for this device. And doing it here will change the area on all the entities linked to this device. Now that we've linked our Assist in Progress entities to an area and we've assigned a label, we can create the template. For reference, you can find the template in the written version of this over on slackerlabs.com. There's a link in the description. Now, the easiest method is to go grab that template from slacker-labs.com. Copy it, and then let's head over to Developer Tools. Click on Template, and if you need, hit the Clear button. Then we can paste in the template. Depending on how you labeled your devices, you may need to make some modifications. So let me walk you through what this template is actually doing. For those of you that didn't watch my videos on Home Assistant templates, the double curly braces wrap something you want to output, or, for the lack of a better term, provide something you want to use in another place inside of Home Assistant. Inside is Jinja, and it will work like programming code. Home Assistant will evaluate the instructions you put in here and provide you the result. So first we want to grab all of the label entities for the label we use to group our Assist in Progress entities. This is what you're going to want to update with the label you used for those Assist in Progress entities. Again, for me, it's Jarvis. Then we provide a pipe character, which allows us to take the output of the expand function and transform it more. So we will sort all of our entities by the last changed attribute. For those that don't know, last changed is the timestamp in which the state last changed. And in this case, sort is in ascending order by default, which means the most recent entity is last in this list now. Then we use pipe and use the map function to strip out all of the entity's information, so we just get entity ID. Then we use pipe followed by list, which turns our group of entity IDs into a Python list. Then we use pipe followed by last, which filters all of this down to the last entity in our list. Then we use pipe followed by the function area ID, which gives us the area ID. You could use area name, which will be more readable. But ID is what we're going to need to ensure that we have the right area, and we can use it in another template a bit later. Once you feel good about the template and it's finding the right area, then it's time to create the sensor. There are two ways to do this, and you can pick either one based on your preference. First, we'll create the sensor in the UI. But if you would rather do it directly in the YAML, which ends up a bit cleaner, then skip to the next section. First, let's copy this template we created. Then we'll head over to Settings, Devices and Services, then click Helpers here at the top. Now we can come down to the bottom and click Create Helper. In this list, we want to choose Template, and because we're doing this in the UI, we're actually going to create two templates. So click Template a Sensor. For name, we're going to call this one Last Assistant ID. And we're going to paste in the template we just tested, making sure our label here is the one we are using for our Assist in Progress entities. And if you scroll down to the bottom, you'll see the value of this template. And in this case, it's probably going to be a GUID, which is the ID of the area. So now that we've created this, we can hit Submit and then Finish. Then we're going to create another helper. Again, Template a Sensor, and this one we're going to call Last Assistant Name. We're going to paste in that template again, but we're going to change the last bit here to area_name. Again, if you scroll down to the bottom, you can see that it's now displaying the friendly name of the area that the last assist in progress was. And we can hit Submit and Finish. So now we have two sensors here that we can use with our voice assistants. Now, a better way to do this would probably be to use YAML. For this, we need access to our YAML configuration files, and I'm using the Studio Code Server add-on to give me access, which is a good add-on to use when you're working with your YAML configuration files because you can edit them right in the browser. To create this sensor, we can either add this to our configuration.yaml file or wherever you've specified your templates. In my configuration.yaml file, I have this right here, template::include temple.yaml, so that I can separate out my templates from the main configuration.yaml file. But if you don't have this, you can just put it under this template: command, and I'll show you what that looks like in just a second. But since I put mine in this template.yaml, I'm going to head over there first, and I'm going to copy the code from slacker-labs.com and paste it in here. Now, this all goes under a sensor colon section inside of this template.yaml file. You will need to make sure to update this to match whatever you've set up in your system. And it's always good to have a unique ID. This looks a little bit different than the one we set up in the UI. But in this way, you get everything combined into a single sensor called Last Assistant. And the main state of the sensor is going to be that template that gives us area_name. Then we're going to have an attribute section in which we set up an attribute called area_ID, and we paste in the template for that. Now, if you wanted to put all of this straight into your configuration.yaml file, it would look like this. Instead of this include template.yaml, you would just have a template colon section. Under that, you would have to indent a couple of spaces and create a sensor heading. And then everything else would be exactly like it was in the other file. I've included all of this code in that written guide over on slacker-labs.com. Regardless of where you make your change though, you're going to want to go back into your developer tools, go to that YAML section, scroll down to templates, and hit the link for templates, which is going to reload your templates. Next, the easiest solution is to grab the YAML from the guide in the use case example section. Just copy it and head back into Home Assistant. So let's head to Settings and then Automations and Scenes. And then we're going to click Create Automation. Choose Create New Automation. Then head up to the three dots in the upper right and choose Edit in YAML. And paste in the YAML we've copied from that guide over on slacker-labs.com. Also, don't be alarmed if this syntax looks different than the YAML you've seen in the past. The Home Assistant team recently updated the nomenclature, but all of the old stuff still works. And to make this easier to walk through, I'm going to head back up to the three dots and click Edit in Visual Editor. In the When section is a voice command we want to trigger this automation with. And this one is slightly different than the one I used in the demo because I've already have defined that elsewhere. And I didn't want this to be colliding with that automation. And this allows this automation to be copied easily. You can change this command to be whatever you want though. But as you'll see here in just a bit, the result of this automation will be the same. The only thing that's different is the command used to trigger it. Next, under Then, we have the response section, and the value of this is just a space. We do this to prevent Home Assistant from responding with done, because it executed our automation, which I find personally annoying. After that, we have a variable section, where we have three variables defined. Area ID, which is the current value of that attribute area ID of the sensor.lastAssistant. Area name, which is the current state of the sensor.lastAssistant. And a media player. The media player is using a template we haven't discussed yet. And to make it work, you may need to do some work. Namely, adding a label to all of the speakers in each area you want to use for the text-to-speech response. In my setup, I'm using Google Home Minis. They're cheap, and Home Assistant integrates with them over the local network, and not the Google Cloud. But you could use any speaker you have as long as your text-to-speech service can use those speakers. Just make sure each speaker is assigned to the area that your voice assistant device is in, and each speaker has a label that separates it from your voice assistant devices. In my case, the label is Google Speakers. So in this template, we get a list of all of the entities with the label Google Speakers. We filter the results to the area, and we're going to use the variable area ID that we've defined above, and then make sure that it grabs the first one it finds. Now, every time this automation fires, it's going to find the area ID of whatever area the last assistant sensor is pointing to, and provide us with the media player in that area. If you've set up the sensors using the UI though, you're going to need to update these variables. Area ID will need to use the states function and the sensor.lastAssistantID, and area name will need to point to the sensor.lastAssistantName. With all of that in place, we can go to the last action, which is to provide a response using the text-to-speech service. Unfortunately, since I've used templates in the values of this action, we're not going to be able to use the visual editor. But you also can use any text-to-speech service you have set up in Home Assistant. Here I'm using the Nabokasa Cloud because I think it sounds pretty good. Regardless of the action though, you need to make sure that the variable media player is what you provide for the media player in your text-to-speech action. If you've assigned your labels and areas correctly, the value of this variable should be the media player in the room when you use your voice command. And in message, we're going to simply put you are in the, and then we're going to use the variable area name wrapped in the curly braces. Once you've made any updates, you can hit save and rename this automation if you would like. Now that you have your automation saved, you can test it out. Hey Jarvis, do you know where I am?
You are in the Slacker Lab studio.
Once you have this capability, you can start to create some really smart voice commands because you no longer need to include area in the command or even hard-code your devices inside of your voice command automations. Personally, I think this should be functionality out of the box. I have some upcoming videos where I'm excited to show off just how far down this rabbit hole we can go. We're talking replicating the functionality of an LLM all without an actual LLM, and all of it can be completely local for those of you not wanting to use cloud-based LLMs. In fact, some of this smart functionality using areas and labels was shown off in this video. Did you catch what it was? Let me know in the comments what you think it was. I'm working on a video to show you how to set that up soon. So if you aren't already subscribed, hit that button and let's automate some boring stuff.